back to get great at maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to represent maths. So let's get ready to get great at maths. I'm going to look at all the differentiation rules you're going to need to know to pass your A-level maths exam. For key formulas, I'm going to show you the equation y equals whatever the function is, and then show you how to differentiate it, then give you an example of how to use each of these formulas. So to start with, we're just going to start with the basic formula y equals x to the power of n. Normal rules for differentiation: you multiply by the power n, times by x, and then take 1 from the power, so it's nx to the n minus 1. Now, if we use an example, if I have y equals x to the minus 2, if you have any function, always write it as a negative indice if it is 1 over, just to make it much easier to differentiate. So we're going to multiply by that minus 2 to give me minus x, 2x to the power of take 1 from minus 2, which gives me negative 3. The next rule is y equals e to the f of x. Now, to differentiate any function in terms of e, we need to multiply by the differential of the function of x. So dy by dx is f dashed of x e to the f of x. An example of this is y equals e to the x squared plus 4x. If I differentiate x squared plus 4x, gives me 2x plus 4. So dy by dx is 2x plus 4, all multiplied by e to the power of x squared plus 4x, where the power doesn't change at all. The next formula is y equals ln of f of x. So to differentiate this, dy by dx is equal to the differential f dashed of x over f of x. So remember, when you differentiate ln x, it's 1 over the function f of x, then you have to multiply by the differential of the denominator f dashed of x. So if I've got y equals ln of 5x, dy by dx becomes 1 over 5x, which is 1 over the function, times by the differential of 5x, which is 5. The 5's will then cancel, leaving me with 1 over x. The rules in red are the key formulas, so please write them down and highlight them. Make sure you know those key formulas for your exam. The blue ones are examples of how to use each of these formulas. The next formula is really important, and this is a chain rule. Now, dy by dx is equal to dy by du times by du by dx. Now, the chain rule is really important when we have to differentiate parametric equations, and it can be used to differentiate the next function that we're going to look at, y equals f of x to the power of n. So the general rule here is we take the function in the bracket to the power of n, so we times by the power, so we get n f of x, take 1 from the power like normal. Then we have to multiply by the differential of what is in that bracket, so it becomes times by f dashed of x. So dy by dx is n f of x to the n minus 1 times by f dashed of x. An example of this is if I've got the function y equals 5x to the power of 4 plus x all to the power of 7. So I'm going to multiply by the 7, write the bracket exactly the same and take 1 from the 7 to give me 6. Then I've got to multiply by what's in the bracket. So the differential of 5x to the 4 plus x is going to be 5 times 4, which is 20, x to the power of 3, taking 1 from the power, plus the differential of x, which is just 1. So my answer becomes dy by dx equals 7 bracket 5x plus 5x to the power of 4 plus x all to the power of 6 times by 20x cubed plus 1. The next rule is a key rule that you need to know. Y equals a to the power of x. So dy by dx is equal a to the x ln a. And you may be expected to prove this in your exam. Y equals 4 to the power of x. So here's an example. So we're going to replace all the a's with 4. So dy by dx is equal 4 to the x ln 4. I have got another video on how to do the proof of y equals a to the power of x. Is dy by dx is equal to the a to the x ln a. If you're interested in seeing more, have a look through my other videos. Here we're going to look at the main 3 trig functions to differentiate. Now you should know that the differential of sine x is cos x, but we've got the function y equals sine of f of x. Now the differential of sine of f of x means we've got to differentiate this f of x to be f dashed of x, and the differential of sine is cos, so dy by dx is equal to f dashed of x cos of f of x. An example of this is y equals sine of 4x. The differential of 4x is 4, so dy by dx is 4 cos 4x. The next trig function is y equals cos of f of x. The differential of f of x again is f dashed of x, but this time dy by dx equals minus f dashed of x sine of f of x. So you need to remember, if you differentiate sine you get cos, but if you differentiate cos you get minus sine. So y equals 7x. The differential of 7x is 7. So dy by dx is going to be minus 7 sine 7x. The last function on this page is y equals tan of f of x. The differential of tan is sec squared, and this is given in the formula book. But more specifically, I have got f dashed of x times by sec squared of f of x. In the formula sheet, it is given in terms of k. So you've got k sec squared of kx. More generally, I've used the formula here, so f dashed of x sec squared of f of x. An example of this is y equals tan 2x. The differential of 2x is 2, so dy by dx is 2 sec squared of 2x. All the formulas we're going to look at on this page are all in the formula book. So these are the reciprocal trig functions, and these are given to you, but they are given in terms of x. I'm giving you a more general form in terms of f of x. So if I've got y equals sec of f of x, dy by dx is f dashed of x sec of f of x tan of f of x. So I've just generalized the formula. Remember, you just need to multiply by the differential of the thing after the trig function. So an example of this is y equals sec of 4x. The differential of 4x is 4, so dy by dx will be 4 sec 4x tan 4x. The next one, also given to you in the formula book, is cosec of f of x. So dy by dx is equal to minus f dashed of x cosec f of x cot f of x. Remember, you multiply by the differential of f dashed of x, then you do what it says in the formula sheet. So for example, if I'm differentiating cosec of 7x, dy by dx will be the differential of 7x, which will be 7. It's going to be minus, so it'll be minus 7 cosec 7x cot 7x. The next one is y equals cot of f of x. So again, we've got to differentiate the f of x to give me f dashed of x, and we're going to multiply by that. So dy by dx is f dashed of x cosec squared of f of x. This is an example, y equals cot of 2x. dy by dx will be the differential of 2x, which is 2, cosec squared of 2x. The formulas in red are your key formulas. Write them down, highlight them, make sure you know what they are, and so you can use them in your exam. The product rule isn't given in the formula sheet, but you will be expected to know it. And the product rule is when you've got two things multiplied together. And it is normally used within an implicit differentiation question. So it's quite tricky to spot this question. So make sure you're looking. As soon as you see two things multiplied together, you are using the product rule. And the top of the quotient rule that we're going to look at next is linked into the product rule. So I'll show you that in a second. So the product rule is dy by dx is equal to u dv by dx plus v du by dx. Now what that means is the first term, okay, which is our u term here, so my u term here, my first term, times by the differential of the second term. So the second term is v, so the differential of the second term is dv by dx, plus the second term, which is v, times by the differential of the first term, which is du by dx. And that's how we say it. So we say it's the first times the differential of the second plus the second times the differential of the first. So use an example here. My first is 4x. So the differential of 4x is going to be 4. The differential of sine x is going to be cos x. So I've got the first times the differential of the second plus the second times the differential of the first. So dy by dx will be the first, which is 4x, times by the differential of sine x, which is cos x, plus the second, which is sine x, which is here in purple, these two are the same, times the differential of the first, which is times by 4. I can then tidy that up to give me 4x cos x plus 4 sine x. The next one we're going to look at is the quotient rule, and this is given in the formula book. So when I've got y equals u over v, dy by dx is equal to v du by dx minus u dv by dx, all over v squared. In terms of words, we can say it is all over the bottom squared. So it is the bottom, which is v, times the differential of the top, which is du by dx, minus the top, which is u, times the differential of the bottom, which is dv by dx, all over v squared. That's how we say the quotient rule in terms of words. It is given to you in the formula sheet. This numerator section here with a plus in the middle is the product rule. So you can use that to help you remember the product rule. So if I look at an example here, u is going to be sine x and v is going to be e to the 2x. So when I put that into the formula, I'm going to put it all over the bottom squared. So the bottom is e to the 2x all squared. So it's the bottom, which is this bit in purple, e to the 2x, times by the differential of sine x, which is cos x, minus the numerator, which is u, so sine x, times by the differential of the denominator, and the differential of e to the 2x is 2e to the 2x. I can then tidy this up to give me e to the 2x cos x minus 2 sine x e to the 2x, all over e to the 4x. Differentiating implicitly normally links in with the product rule. Now, when you're differentiating implicitly, you need to differentiate any y term, and then basically you add dy by dx when you multiply by when you differentiate any y term. So if I'm going to find dy by dx when x cubed minus 4y squared is equal to 12xy. So the differential of x cubed is just 3x squared, nice and easy. The differential of 4y squared, the differential of 4y squared, now 2 times 4 is 8, so 8y, take 1 to the power of 1, and because this is a y term, I need to put dy by dx afterwards. So this becomes minus 8y dy by dx. Now the last term here, we're going to use the product rule on because I've got two terms multiplied together, where u is equal to 12x and v is equal to y. So I've got the first, which is 12x, times by the differential of y, which is dy by dx, plus the second, which is y, times by the differential of the first, which is 12x, which is 12. So I end up with the function 3x squared minus 8y dy by dx is equal to 12x dy by dx plus 12y. I can now put my dy by dx terms together. So I've added 8y dy by dx to both sides, the blue term, and I've also subtracted this plus 12y from both sides. So my dy by dx terms are both on the right hand side. I'm going to factorise the right hand side and take a factor of dy by dx out on the right. I've written this over on the left hand side. You can swap the sides over. So leaving me a factor of 12x plus 8y all times by dy by dx is equal to what was literally on the left hand side now comes on the right hand side to be 3x squared minus 12y. If I divide by this 12x plus 8y, I get dy by dx is equal to 3x squared minus 12y over 12x plus 8y. So generally you need to rearrange to find dy by dx. Sometimes you're given values for x and y, and it is easier to substitute those values in right at this initial stage up here on this first line here. So if you substitute those x and y values in, it makes it easier to work out dy by dx if you are given those values. We're now going to look at differentiation from first principles, and this is a formula that is given to you in the formula book. So it says that y equals f of x, dy by dx is the limit as h tends to 0 of f of x plus h minus f of x over h. Now it's really important that you use this notation at the beginning of limit of h tends to 0. And we're going to look at an example to show how this works. So if y is equal to 4x squared minus 2x, my function f of x is 4x squared minus 2x. So when I put f of x plus h, all I've got to do is replace all the f of x plus h. I'm going to replace all the x's in this expression with x plus h. So this x here after a 2 becomes x plus h. And then the original function that was given in the question, 4x squared minus 2x, is my minus f of x. So whatever the question is what you're taking away. It is always over h, that doesn't change, so whatever function you're given, it is always divided by h. The tricky bit is substituting in x plus h into the function that you're given instead of x. Then once you've done this, it is a bit of algebraic manipulation. Remember to always include this limit of h tends to 0 at the beginning. It's really important that is there. So we're going to expand the brackets. So if I expand x plus h all squared, gives me x squared plus 2xh plus h squared. Expanding the brackets here gives me minus 2x, 2 times x is minus 2x, and minus 2 times h is minus 2h. Then that's going to be subtract the 4x squared, and then the minus times the minus makes a plus 2x on the end. Next, we're going to look at cancelling. So I've got a plus 2x and a minus 2x, which will cancel. And I'm just going to expand the brackets here at the front and simplify. So I've got 4 times the x squared gives me 4x squared. The 4 times the 2xh gives me the 8xh. 4 times the h squared gives me 4h squared. The minus 2x and the 2x cancel, leaving me with the minus 2x and the minus 4x squared. From here, I can see that my x squared terms will cancel. So I've got a plus 4x squared and a minus 4x squared term, which will cancel. And all the remaining terms are left with a h in them. So I can factorise out a factor of h of each of these 3 terms remaining in the numerator, leaving me with h times by 8x plus 4h minus 2. Now the h at the numerator here at the front and the h in the denominator will now cancel, leaving me with what was in the bracket. So it's the limit of h tends to 0 of 8x plus 4h minus 2. Again, it is really important that you've still got this notation of a limit as h tends to 0 at the front. From here, h is now going to tend to 0. So that means this h term here in the middle is going to become 0, because 4 times 0 is 0. So all we're left with is 8x plus 2. So as h tends to 0, 4h tends to 0. It's really important you state what you are doing at this stage here to show that you understand that the h has gone to 0, so this term here just disappears because h is now 0, which means dy by dx is equal to 8x plus 2, which is what we would have expected in the first place if we'd have differentiated it, because 2 times the 4 gives me 8, x, take 1 from the power gives me 1, and then we've got minus 2x to the power of 1, so minus 2 times the 1 gives me minus 2, x, take 1 from the power, 1 take away 1 is 0, which is why it's minus 2x to the power of 0, x to the 0 is 1, so it's just minus 2 times 1, which is minus 2 here on the end. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!